Hi, everybody, and thanks for joining this session. My name is Hever, and I'm an algorithm developer working currently for VisionMap. And today we are going to be talking about automatic speech recognition. We will briefly review and summarize the main principles of this field, and we will also talk about the progress, research, and the challenges that it deals with. But before we start, I have a small confession. I spent hours lately sending silly questions to ChatGPT. And I guess that we all know that OpenAI has launched lately its new chatbot. And we all spent hours asking this AI to useless questions about the meaning of life and if God exists. So do I. And actually, I was delighted from reading its fantastic answers. And for those of you who didn't hear about the new breakthrough, ChatGPT is a virtual assistant that allows users to have human-like conversations. And well, actually, when I was preparing this presentation, I played around with ChatGPT and asked it to write down for me a title to this lecture. And this is the result: Exploring the Future of Automatic Speech Recognition, Advancement, Challenges, and Opportunities. So why did I mention that? Because it was a short example of one of many technologies that are so-called conversational AI. Basically, this term refers to a bunch of technologies that humans can interact and communicate with. And today, I want to focus on a subtask of this domain that is called automatic speech recognition, which refers to technologies that recognize and translate a spoken language into text. It is also known as speech recognition or just speech to text, and I will name it here from now on ASR, just for simplicity. So basically, ASR is everywhere, from our offices to our houses. We all talk with our appliances, and our devices can be automatically controlled via voice. For instance, some of us use Siri in their smartphones, some of us use Alexa in their smart homes. And the popularity of smart devices has made us feel the convenience of voice technology. And interaction via voice is inherent and natural for us as human beings. Google reports that more than a quarter of the global online population is using the voice search feature on the mobile devices. So this domain was starting intensively to be researched over approximately 70 years ago in the Bell Labs in the States, which made the first truly complete speech recognizer that could recognize 10-digit by its physical signal. And in the mid-80s, there was a major advancement with the introduction of statistical models, and the hidden Markov model combined with the Gaussian mixture model becoming the major and dominant model used at that time. However, after years of development, the HMM-GMM model has reached its bottleneck, and there was little room for further performance improvement. And one of the most significant advancements was the adoption of deep learning in 2011, which marked a shift away from the long-standing use of HMM-GMM. And in 2014, Baidu's Deep Speech was released and faced with the challenge of building an end-to-end model. Until that time, models were divided into 3 independent modules that played a different role and were optimized separately. And the end-to-end models eliminated this gap and simplified the training process by building a joint loss function and a direct output. However, the end-to-end models were more demanding in the amount of labeled data that required to achieve good performance. And beyond that, this field has been heavily influenced in the last decade by development in parallel worlds and other areas such as computer vision and natural language processing. And the pre-trained language model has shown great success and achieved state-of-the-art performances in many NLP tasks. The idea of creating word representations by massively learning unlabeled data through masking and sentence ordering was adopted a year later to build the first self-supervised learning speech representation model in this domain. So where we are. WER is a rule of thumb and the major metric used for measuring the number of word additions, substitutions, and elimination by the evaluated model. And it is also the acronym of the term word error rate. And this graph is showcasing the word error rate of the state-of-the-art approaches by paper with code over the years. And as you can see, in 2016, for the first time in the history, deep speech showcased performance that surpassed human abilities, which was really impressive. And in 2018, different versions combined with the augmentations were published, and we can see we are witnessing to a drastic increase in performance a year later following the entrance of self-supervised learning to this domain. Since 2020, every few months, another paper is announcing a new state of the art, and it opened the door for many more new approaches that are coming later. So in this graph, we can see it even better. I took it basically from the Dimension AI website, and here you can see the amount of papers that were published every year along the last 50 years in the field of speech recognition, of course. And we can see that this number has doubled in the last decade. You can also see that there is a steep drop around 2010, and probably because HMM, GMM models eventually reached a performance plateau. And then around 2011, when deep learning entered the game, the number of articles began to rise again. Between 2019 and 2020, there is a sharp slope of around 20%, which is the sharpest increase since the field has first been researched. So it was an optimistic view of the overall ASR accuracy, which was met with the resistance of a few different research groups, which claimed that this misconception might be caused due to the confounding of two regimes in this field. One is the chatbot-like interaction, when humans are fully aware of speaking to a machine. Most of the people will shorten the sentence and simplify their utterances. And the other one is the spontaneous human-human conversation, which are more lively and dynamic. And Where We Are and Where We Think We Are paper that was published 2 years ago, it reported that benchmark data sets do not represent and reflect the spontaneous real-world conversation, and thus do not provide reliable estimation of the actual ASR accuracy that is grossly overestimated. And out of 1.5 billion people who speak English, less than 400 million use it as a first language. That means that over 1 billion speak it as a secondary language with different speaking styles and typical pronunciation. So another group of researchers from Stanford published a paper that is called Racial Disparities in Automated Speech Recognition. And they compared leading ASR services and found that the average error rate is higher substantially for Black population versus a white population. And given this fact, the same language is used in many different demographics, and language always changes. New generations pronounce existing words differently, slang and informal phrases are in and other out, and benchmark data sets and ASR systems should constantly have to adapt themselves to the latest version. So hopefully in the coming years, we will see a vast progress in building new data sets and speech recognition tools that work well for everyone, including people with speech impairments, regardless ages, accents, and dialects, and overall get integrated better into our daily life. So just to wrap things up, although this field made huge progress in the last decade, researchers continue to benchmark and develop approaches that improve and recognizing spontaneous speech in everyday life, where background noise and speaker overlap are more common. And before ending up, I want to talk about the near future and what does the future hold for ASR. So today models get millions of audio snippets for producing text, but do not take the advantage of all the abundance of information that exists. And only 7% of human communication is made up of the words we say, and the rest is how we say it using our tone of voice and body language. And if you remember, not long ago, we had to work with masks, and it had been almost impossible to understand each other. So thus, recently, researchers started to develop machines that are trying to imitate the way people learn new skills in order to closer the human brain. And in the next decades, future AI tools could listen to users and understand the meaning behind the words. And recently, more and more works include aspects of spoken content along with non-lexical information, for instance, the way it is delivered and using emotions and lip movement, etc. So that's it. I hope that this lecture was beneficial for you. And if you have any question, feel free to ask me here, or you can reach out later in one of those platforms. And thank you very much.